Welcome back to part 6 of the Griffin tape deck. Welcome back to part 9 of the Griffin tape deck restoration. And here we're going to actually take a look at the replacement of the pots that got burned out when all the capacitors leaked and drew excessive current and everything. So that's important. And if you go back to part 7, if you want to see the inside of one of those wire wound pots and what burned out, I get a chance to show that to you. So you can go back to part 7 for that. Part 9, we're going to actually replace the parts, but surprise, surprise, they don't fit. Well, here's what I did to take care of that. 1 coffee cup later and a pit stop thereof, ready to go after these pots. Turns out they arrived while I was on coffee break. Only needed 1 of each, so when you need 1, you buy 3. I couldn't get a 3-watt wire wound pot at 5K. It's just not available, but what I did was I got a 4700. So it's 4.7K versus 5, but at 3 watts. And that should be just fine. Yeah, he said should be. And then the 10Ks, which are 1 watt, a wire wound pot is going to handle more current than a carbon film type potentiometer rheostat would. The pot itself is going to go in this hole right here. This is bias for one channel. This is bias for the other channel. This one works, that one didn't, and it's about to. Those are the 4700s. That's going to go in place of this pot over here because this pot turns out it's also bad. Why did the pots burn out in the first place? I mean, I just got done saying that, you know, you use a wire wound so it'll handle more current, and yet clearly it didn't handle it too well. I want to get this in here. It's going to be too close quarters. The other pot's in the way. It won't quite fall into that hole because the diameter of this pot is larger in diameter than that pot. When I get over to here, it's not going to be a problem because there's a lot of space around there to deal with. The only way I can see to fix that is to open up this hole just a little bit so that I can slide this over enough to where it'll clear this other pot right here. I'm wondering if I can use a nibbler tool just to sort of notch this over in order to make enough room for that, and that the washer and the nut that's going to hold it in place will work. This, ladies and gentlemen, is the nibbler tool. One very important thing about this now is that as I nibble this, each piece of nibbled material, nibbled steel, you have to account for them. You don't want them just lost in the circuitry here somewhere that one day it's just going to short something out. So with each one, with each snap of the nibbler, I'm going to want to make sure that I have collected the scrap. And boy, I mean, just getting the nibbler in there, this pot's sort of in the way now. The only right thing to do is to take this pot out and get it out of my way so I can get the nibbler in there and open this up. I want to be really careful because this pot is still good. Ordinarily, I would use a nut driver on that nut down there, but that looks like it's probably a 1/2 inch. First nibble. I just want to keep track of my scraps. There it is. I think the thing to do with this part is actually just come up here at a slight angle. So it didn't bite a lot, but it bit some. So you can see here that this pot now, this is probably the position where it was, but now I can move it over that far. It'll clear the space needed for this pot. I do want to get these two very close together because this little piece of wire right here actually was soldered between the two of these in order to take these cases to ground, sort of shielding, because there's a 70 kilohertz-ish signal at about 150 volts that's coming through these pots, so it wants to radiate. So they grounded these cases in order to prevent extraneous radiation of that RF signal. Yeah, it's only 70 kilohertz, but I still consider it RF. Because this pot is larger in diameter, it might tend to touch this barrier strip right here with a couple of layers of electrical tape, just in case it ever tries to like rub through there or something. Now we'll get the new pot into position, or a newly nibbled hole. Not only that, but I'm also counting on this washer to hide the multitude of sins that occurred in making that hole accommodate this new pot. I've desoldered the leads and the extra wire wound resistor off of there, the 5K. So we've got this out. I'm going to go ahead and just measure from end to end. Lo and behold, it's open. All right, so it's a wire wound pot. There's a break in the winding inside this pot somewhere. If I take and turn this shaft, at some point I'll probably, yeah, right there. So the wiper actually made connection with the part of the wire wound that actually does work. I can probably come back to this side. I go from 1.2, maybe 1.6, no, 1.3 to open, and from this end, 1.5, that's it. So 1.3 ohms from this point to somewhere over here, and then from here to someplace right over here. All of this inside this pot here is gone. This new pot, although not 5K, is 4,700, so 4.7K. It's going to be pretty close, and it's going to do the job. I really have a good feeling about this. Now, you might be asking yourself, well, why is there even a dummy load in this unit? This unit is actually capable of recording one channel at a time, the left channel or the right channel, 1 or 2, all right? And as a result, if you switch from stereo mode, where you're erasing 2 tracks and biasing 2 tracks at a time, then when you switch to, in this case, it says upper or lower, then you're only going to be recording one channel and erasing one channel, but there's still plenty of excess voltage there. So they put a dummy load in this circuit here. So when you switch from stereo and to one track only, it's going to switch in a dummy load to simulate the load that would be there if you were doing 2 tracks at a time. And that's what the dummy load is for. The pot that came out was 5K with a 5K fixed resistor across it in parallel, which means that at best, the most resistance you were going to get with those 2 in parallel was 2,500 ohms. You know, later on, there became more efficient ways of being able to do that, but this is ingenious. Now that I've got this basically upside down, you see the actual, business end of this particular chassis. Just to sort of touch base here real quick, this is the new bias pot that has been put inside. This is an original pot that tested okay, so it got to stay. Both of these are 10K, so those 2 are done. This is the new 4.7K pot, which is going to be for the dummy load. This pot here checks out fine. It is also a 5K pot, but this pot is actually important in this way. It's basically a balance adjustment between the signal going to the oscillator too, because you got 2 triodes. So by adjusting that pot, you can actually adjust the gain so that the sine wave is symmetrical, and that's important. With the pot wide open and that 5K pot across there, I've got 2.46. All right, but now as I adjust this, and I'm going to get to where I think it's about halfway, that's totally closed off. I have pretty good range on there. So the last thing to do is to go ahead and reattach this shield wire. And I think this new pot over here, this 4.7, is actually smaller in diameter than the pot it replaced, whereas this one was bigger than the one it replaced. This is smaller than it was replaced. That wire is going to be shorter to go the distance, so let's just do this. Let's just replace that wire. And so I don't want to risk heating this end of the wire up and having it simply melt the solder on the other end. All right, because that's going to be, you know, it falls off there and it's going to be a pain in the butt. Here's what we do. Just put a hemostat on there, which will act as a heat sink so that the heat cannot get to that other solder joint. And we just flow some solder onto this. And that is a done deal. Success. Okay, I've got the pots installed. Now I've got to do the full-on check to make sure that the circuit is actually doing exactly what it's supposed to be doing. And that's what we're going to do in our next episode. If you like what you've seen, give us a thumbs up and subscribe. It keeps you on notice that the episodes are dropping. All right? And your comments, appreciate those, and we're responding to you. It's giving us a great idea of the things that we're going to be doing next. Okay? Patreon subscribers, thank you so much for contributing. It's really important to us, and it's important to you because you gain access to detailed episodes and service manuals and any kind of other documentation. I mean, I might draw a funny picture. Well, that's yours if you're a Patreon subscriber. Appreciate you guys a whole lot. Thanks for watching, and we'll see you in the next one.